FFF stands for Fused Filament Fabrication. It's a form of material extrusion printing where the printer takes thermoplastics like PLA and ABS, melts them, and then layers them down into specific shapes. We studied and used it in class because it's the cheapest and most available form of 3D printing, and it's common among hobbyists. So SLS and binder jet printers, neither one require supports to form their parts, because the way they work is they take a bed of powder and then create the layers either by sintering powder on the top or by extruding droplets that bind the powder together. And then once the layer is formed, it's lowered down and covered by more powder. And so this powder is constantly surrounding and supporting the formed piece within the bed. Okay, a cause of warping could be poor bed adhesion. The bottom layer isn't sticking to the build plate, the edges could potentially peel up and warp. Another is unwanted or uncontrolled cooling. So as things heat up, they expand, and as they cool down, they contract. And so if your part is cooling in ways or more significantly than you wanted, it can cause it to warp. And a third cause could be an uneven bed. Some solutions could be printing in a heated enclosure to keep the part from cooling down too much, and another could be applying adhesive like glue or hairspray to the build plate to increase bed adhesion. Basically, 3D printing is the process of taking a material and having a machine form it into a very specific shape. So this is done by first designing the part, then slicing it into very thin layers, and then having the printer, the machine, create each layer individually on top of each other. And this can be done in a variety of ways depending on what type of printer you're using. But after it's done that, you'll have a finished part, and then you may just have to clean it up a little bit to get your finished 3D print. Okay, these are some types of 3D printing materials. So PLA is the easiest to print with. ABS is still fairly easy, but it's significantly stronger than PLA. Nylon is often used in the aerospace industry. Resin is weak but high resolution, so it's used for visual, non-functioning parts. And metal has uses in dental and medical fields. One reason a print might not be sticking to the bed is because the extruder may be too far away from the bed, and so the material isn't being forced onto the bed properly. It is more just dripping out. Another could be that the bed isn't level, which would cause, in some areas, the extruder to be too far away and some for it to be too close. And third would be improper bed temperature, so the material isn't melting and sticking to the bed. Some solutions could be slowing the first layer's print speed, so that the material has more time to melt in the extruder and is able to be more precisely placed on the bed. A second would be leveling the bed and correcting the Z height, and a third would be adding a brim or a raft. One current use of 3D printing is in rapid prototyping, because of how quickly and cheaply you can make testable parts. Another is in dental modeling, because it's very easy to use 3D printing techniques to model someone's teeth specifically. In the future, we'll definitely see 3D printing being used in extraterrestrial environments. Shipping stuff to space is extremely expensive, and so being able to create parts that are needed in orbit or on other planets is going to be vital. And then we'll probably see mass production of large-scale structures like buildings, houses, etc. Okay, finally, one cause of a 3D printer being clogged could be that the extruder temperature is too low, so the material isn't fully able to melt and leave the extruder. Another could be that the nozzle is too close to the bed, so again, the material isn't fully able to leave. Two solutions could be increasing the flow rate, so the new material will hopefully just push all the old clogged material out, or doing a cold pull, which involves manually removing the clogged material. And that is it. Thank you.